Hello, my name is Aaron Simon, and I was tasked with analyzing a problem from Chapter 5 and showing how to solve it, and the verification that you can do to prove that you solved it correctly. So this is the question that I chose from Chapter 5. What it asked is, make use of source transformations to first convert all three sources in the figure below to voltage sources, then simplify the circuit as much as possible and calculate the voltage Vx, which appears across the 4 ohm resistor. It also asks to draw and label the simplified circuit that we get after we do the source transformations. So the first step to solving this problem is to perform source transformations. Below, I have written the original circuit on the top with a simple change. It's just that this 5 ohm resistor came from combining the two 10 ohm parallel resistors using the equation of R1 times R2 over R1 plus R2. Now, when you're performing source transformations, it's a very simple equation. All you simply have to do is use Ohm's law, which is V equals IR. So let's take, for example, this dependent source, which in source transformations, whether it's independent or dependent, you don't have to worry too much. All you need to do is use Ohm's law. So to get the source transformation from current to voltage, all we have to do is do 5Vx times the 5 ohm resistor, which will give us 25 Vx volts, which, as you can see down here, becomes a voltage source, a dependent voltage source. Now keep in mind, when you're transforming from current to voltages, the current source and the resistor that's in parallel with become a voltage source and a resistor that's in series with it. As you can see, we have 3 volts in a series with a 1 ohm, and then the dependent source becomes in series with the 5 ohm resistor, and then this 9 amp current source becomes an 81 volt voltage source that's in series with the 9 ohm resistor. Now keep in mind as well, make sure that the signs of the voltage source do not get switched. This current source is pointing downwards, while this current source is pointing upwards. Therefore, the signs on the voltage sources must be flipped as the same with the current sources. So the negative would be on top and the positive would be on the end for this 81 volt voltage source. So the next step would be to perform mesh analysis. So I've written below the simplified circuit and assigned two currents to the left mesh and the right mesh, which I've labeled as I1 and I2 respectively. Now, when we do KVL on the left mesh, which I've labeled below, we get -3 plus 3I1, which is the combination of the 1 ohm resistor and the 2 ohm resistor to get 3. Then plus 7 parentheses I1 minus I2. Now, the reason why I did I1 minus I2 is because the 7 ohm resistor is between two currents, and so we must do I1 minus I2 with I1 being in front because we're analyzing the left mesh. And once we simplify this equation, we get 10I1 minus 7I2 equals 3, and that is our first equation. Now moving on to this right mesh, we get minus 25 4I2. Now the original is 25 Vx, but we've labeled Vx to be on the 4 ohm resistor, and Vx according to Ohm's law would be 4 times I2, since I2 is the current running through this right mesh. So then that's how we get the minus 25 parentheses 4 I2. Then we get 14 I2, which is the combination of the 5 ohm resistor and the 9 ohm resistor, plus 4 I2, which is the 4 ohm resistor, minus 81 from the voltage source, and again 7 I2 minus I1, which is the same as the one on the left, but I2 is in front because we're not analyzing in the right mesh, equals 0. And once we simplify this, we get our second equation of 7I1 minus 7d5 I2 equals 81. The third step is to solve the two systems of equations that we've gotten for both I1 and I2. Or in this case, since we just need to find the value for Vx, all we need to do is find the value of I2. So if we take the equation, the first equation that we got on the previous slide, we can simplify it to have I1 on the left side only and get 0.3 plus 0.7 I2. And if we substitute that into the second equation, we get minus 7 parentheses 0.3 plus 0.7 I2 minus 75 I2 equals 81. And once we simplify this equation, we get I2 equals negative 83.1 over 79.9. And then we plug this I2 value into the Ohm's law equation that we get for finding Vx, which is Vx equals 4 times I2. And then we get a value for Vx being negative 4.16. Now, to verify that we got the correct value for Vx, we can verify using nodal or KCL. So, I've rewritten the simplified circuit and labeled the node above the 7 ohm resistor as V. Now, we can find the voltage for V by doing 7 I2 minus I1 and plugging in the value of I2 and solving for I1. So when we take the equation from the previous slide for I1, which is the 0.3 plus 0.7 times I2, we can simplify it to get I1 is equal to negative 342 over 799. Then we plug this back in for the equation for V, so we get 7 parentheses minus 83.1 over 79 minus parentheses minus 342 over 799, and then that simplifies to negative 489 over 799, and then multiplying that by 7, we get V is equal to 4.28. Now, when we perform nodal analysis, we get the nodal equation of V minus 3 over 3 plus V over 7 plus V minus 25 Vx minus 81 over 18 equals 0. Then we can plug in the value for V into this equation and plug in the value for Vx that we solved on the previous slide into the equation and simplify it. And as you can see, A equals 0 on the left side, which is equal to the right side, so we can safely say that we solved the correct value for Vx. And that is it. Thank you very much for listening, and I hope you've learned something from my explanation on how to solve this chapter 5 question. Once again, thank you and have a good day.